Hi everyone, this tutorial is about Multiplexer. Multiplexer, also known as a data selector, is a device that selects between several analog or digital inputs, signals, and forward the selected input to a single output line. So that means it always would be one output. The selection is directed by a separate set of digital input known as select lines. So just like we have here, we have 1, 2, 3, 4, 5, 6, 7, 8, 8 inputs. This is 8 to 1 multiplexer. As you can see, one output, 8 input, one output, and we have 3 selectors. Now, how do we know it's a 3? I'm going to show you that in a minute. Based on the number of inputs, we decide how many selectors. So why do we use it? Because it reduces the number of wires, it reduces cost and complexity of the circuit. Also, to allow us to implement various different types of circuits. So sometimes represented in two ways. Here we have the input and also one output, and sometimes referred to as MUX, mux. Okay, and these are the selector. So they're both correct. So as I mentioned, representation of this is of the multiplexer, sometimes written as mux, and select. So what it does, select binary numbers from one input line and direct it to output line. Basically, just like a clock, which switches between them. So here we have just a quick example. I'm not going to get into details. And here it just says a 4 to 1 multiplexer takes 4 input because it's 4 to 1 multiplexer. 4 is the 4 input, 1 is 1 output. And if it's 4 inputs, then we have, I think, 2 selector. We're going to find out that in a minute. And if it's 8 bits here, input, also we have 1 output. Now, multiplexer consists of 2 to 4 decoder and 4 by 2 and or gate. However, the multiplexer takes 4-bit bus as input and output a single 8 bits, which I'm going to get into details on. Normally, we use this sort of expression logic expression to basically to explain the equation of the multiplexer. As you can see here, we use here y equal as negative S1, negative S0 minus as I0, which is the input, which I'm going to show you some example in a minute. Also, half adder and full adder and combination of circuit can be implemented using max. So now let's have a look at this multiplexer. This is 4-input multiplexer. Why 4 input? It's because here we have 1, 2, 3, 4. So if we have 4-input multiplexer, we have 2 selector variables. That sometimes we call it selector variables. That's why we refer to them as S1 here as 0. I, the input, Y is my output. So when we have S is 0, and S0 is 0, then my output will be 0. So we'll have a connection between the Y and input 0. And when I have a selector 1 is 1 and selector 0 is 1, that basically what we mean here is selector 0 and selector 1 as a first selector, and this is the second selector. Just like here we have the first input, second input, third input, and fourth input. So when I have my first input is 1, my second input, selector here as 1, and the second selector as 1, then my Y will connect, or the output, to the fourth input, or in this situation we call it I3. So let's have a look at this example. Sometimes this is 2 to 1 multiplexer. Why 2? Because of the 2 inputs. 1 because it's always 1 output. And we have only 1 selector. So I refer to it as S0. It's also, this one is correct, 2x1 multiplexer. So as I mentioned, number of output always equal to 1. So here, now the relationship between the selector variable and the input. Yeah, so normally we use this formula, n equal 2 to the power of m. M gives you the number of lines, so m is equal log base 2 to the power of n. Don't worry too much about it, but that's how we get the number of selectors. So when number of here n equal 4, number of input, m equal log to the base 2, here 2 to the power of 2, then we have m equal 2 multiplied by 1, when 2 over 2 is 1. So 2 multiplied by 1, we have 2. Like I said, don't worry too much about this. All you need to understand how it works. So let's have a look at 2 to 1 multiplexer, like I mentioned to you. So like in here, we got 2 to 1 multiplexer. So always number of input line is 2. 4 to 1 multiplexer, 4 number of input line, and 1 here number of output line. So where do we remember that from? When we have 2, 4, 8, 16, 32. Here we go back again to the beginning of computer science fundamentals. Yeah. So when we have is 2, 4, 8, 16 multiplexer, 32 multiplexer, what's going to be next in line? 64 multiplexer. If it's 64 multiplexer, then we have the number of selected variables is going to be 6. And when we have 128, it's going to be number of selected variable has 7, because when we have 2 to 1 is 1, 4 to 2 is 2, 8 to 1 is 3, 16 to 1 is 4 number of selector variable. 32 to 1 is 5 number of selector variables. Selector variables, we're talking about these guys here. And 64 to 1 multiplexer is going to be 6 number of selector variables. So let's have a look at this example. Now, 2 to 1 multiplexer. 2 input, I0, I1, 1 output. Here we have Y. Now, when we have the enable here is 0, circuit does not work, so the output here is going to be 0. Now, when I have the enable is 1, the selector is 0, then my output Y is connected to the first input. So I'll have connection here, therefore Y equals 0. And when I have enable is 1, the selector is 1, then I connects to the I1 input, therefore Y equals 1. So this is input 1, input 2. So we just create this connection. So let's have a look. Before I look into the how we create the logic gates, this in terms of the logical expression. So Y equals E, the enable, and negative S. How do we know that? Because E here is 1. So we just look at this side of the circuit, yeah, of the truth table. So E is 1 and S is 0. So S is negative, and I here is going to be 0, plus E here is 1, or we mean here or, and S is 1 and I is 1. So, or we can just simplify it. We use this basic expression. So let's have a look at the gates here. So we have here, you can see my input. This is my selector, and then his enable. And you can see AND gates, and then OR into 1 output.